Hello students, in today's lecture we are going to learn about Boolean algebra. In last two sessions we have studied about digital electronics, types of numbering system and conversion of one number system into another number system. As we are dealing with digital electronics, we need to understand about the numbering system as well as Boolean algebra is very much essential. This is the next part which we need to understand Boolean algebra. The Boolean algebra, which is invented or introduced by a scientist, is called George Boole. Hence the name is Boolean expression, which is similar like to electronic switch. But electronic switch is a 0 when it is off. Electronic switch is like a 1 when it is a on state. Why this Boolean algebra is required? Basically, to design the logic circuits or digital electronic circuits, this Boolean algebra is necessary. And what it does, the Boolean algebra, which analyzes and simplifies the complicated Boolean circuits or logic circuits or Boolean expressions to make it simple and operate easily and to take less time and operate faster, this Boolean algebra is necessary. This Boolean algebra gives some fundamental formulas which gives some laws. With the help of these identities or formulas as well as laws, we can simplify the complex logical circuits into simple logical circuits. That is the use of Boolean expression in the digital electronics. Let's see which all these formulas are there. So this Boolean algebra, which uses three notation operations, logical operations, it is called logical negation, logical multiplication and logical addition. Logical addition with a positive sign, logical multiplication with a dot, and this logical negation is with a bubble. Now these are the Boolean algebra or fundamentals, you can say. Here the 0 doesn't mean that binary zeros and ones. These are the logical zeros and logical ones. Logical 0 is ground, logical 1 is VCC in the electronic circuits. And this A value, A may be consisting 0 or it may be consisting 1, any values. These things we need to clear first. The thing is, the zeros and ones are not the binary values. These are the logical zeros and logical ones. And this A may be consisting 0 or it may be consisting 1. That means logical 0 or logical 1. Let's see. A into 0 is equal to 0. This is the basic expression. So 1 into 0 is 0. Or if it is 0, A is 0, then 0 into 0 is 0 only. There is not needed any explanations. Second one is A dot 1 is equal to A. For example, if this A is 0, logical 0, and into 1 is 1, A only. So if it is A is 1, then also it is A. Then A into A is equal to A only. Suppose if A consider that 1, 1 into 1 is equal to 1. Or if A you consider 0, 0 into 0 is 0, that is 0 is nothing but A, so it is A only. A dot A bar is equal to 0, that means suppose if A is 0, then A bar is 1, 0 into 1 is 0. If A is 1, then A bar will be 0, so 1 into 0 is 0. Now this is again A plus 0 is A, this is a basic term. Then A plus 1 is equal to 1. Suppose if A is 0, then 0 plus 1 is 1. If A is 1, that is logical 1, so logical 1 plus 1 is 1 only. A plus A bar is equal to 1. That means suppose if A is 0, then A bar will be 1. So 0 plus 1 is 1. If A is 1, then A bar will be 0. So 1 plus 0 is again 1. Then eighth one is a plus a is equal to a only. That means suppose if it is a is 0, so 0, again this is also 0, that means 0 is what? It is a. If it is a is equal to 1 and this is also a is 1, 1 plus 1, it is 1 only, so 1 is what? It is a only. So these are the fundamentals of Boolean algebra which we should know in order to solve the Boolean expression. Why we need to solve the Boolean expression? To make the circuit simple. And there are some Boolean laws. Which are those laws? This first law says that a plus b is equal to b plus a. That means it is talking about addition. And that addition, if you change the order a plus b, instead of that is equal to b plus a, you can add with a with b, or b you can add with a, that remains same. In the similar way, in the multiplication also, you can multiply a with b, or you can b multiply b with a. Both are same. That means in the Boolean algebra, that ordering doesn't matter. Order where it is required in the matrices. If you change the order in the matrices, the answer will get changed. But here it doesn't change. That is called cumulative law, or it is also called commutative law. Next one is a plus in whole bracket b plus c, that is equal to in whole bracket a plus b plus c. This is about the addition he is talking. In the similar way, you can write it for multiplication also. A dot in whole bracket b dot c is equal to in whole bracket a dot b into c. So what is talking about? He is talking about the addition as well as multiplication. Here also same case, but he is talking about the groupings. First you can group this one and you can add with this, or you can add these first to these two terms, then you add with this term. No, same result. If you multiply these two numbers first, then you multiply with this, or you multiply first these two numbers and then you multiply this, the result remains same, and this is called associative law. The next one is distributive law, and distributive law we have used in algebra only. So a dot in bracket b plus c. What is that distribution? A is distributed with b as well as a is distributed with c. That is what here written, a dot b plus a dot c. This is called distributive law. Now here a plus b whole bar is equal to opposite, that a bar dot b bar. So it becomes multiply. And if it is a dot b whole bar, that if it is multiply, then it becomes addition, a bar plus b bar. This is called De Morgan theorem. So this is what all about the Boolean algebra identities and Boolean laws. And why Boolean algebra is required? Because to analyze as well as the simplify the logic circuits, we need Boolean algebra, which makes this circuit very simple to operate, as well as it takes very less time to operate. Hence, these Boolean algebras are necessary. And to use that Boolean algebra, we should know about this Boolean algebra identities and Boolean laws. There is no need of proof and all those things. Only these identities and laws, if we know, that same thing we are going to implement in order to reduce the complex circuit to the simple circuit. That is there for your syllabus. For your syllabus, that proof is not necessary. In next class, I will deal with logic gates, types of logic gates and truth table. Thank you.